Good morning, everybody. In last lecture, we have learned about the periodic table, atomic number, and their configuration up to atomic number 20, valencies, and some periodic trends. Now, today we will study the chapter 2 that includes chemical bonding. Chemical bonding is in syllabus of class 9th and 10th both. So first we will discuss about bond. What is bond? Bond is just a force of attraction which keeps the two particles together. If it is present in the chemicals, so it is called chemical bond. Chemical bond is of mainly three types in class 9th and 10th syllabus. So we will learn about only three types of chemical bonds. First chemical bond is electrovalent bond. Electrovalent bond is the bond which is present between the metal and the non-metal atom. If the metal and a non-metal atom combine together, what is the need of combining atoms? So there are two reasons for this phenomenon that they combine or they form bond. The first reason is that all atoms have the tendency to complete their octet. That's why they have to share electron or they have to donate or receive electrons. Second, they have the tendency to acquire the electronic configuration of noble gas element, zero group elements. These are the two reasons why the atoms combine together to form molecule and why they form bonds. So very first we will study about electrovalent bond. Electrovalent bond is the bond which is formed between metals and non-metal element. This bond is formed between the two atoms of the elements with the electronegativity difference is more. If the electronegativity of two elements is more, then the bond is formed, that is electrovalent bond. Electrovalent bond is also called ionic bond. Ionic bond is the stronger bond than any other kind of bond. It is because this bond has the extra force of attraction and more energy is required to break the bond which is present between the atoms of these atoms. In electrovalent bond or ionic bond, the atoms have to lose or gain electrons. We know that metal elements have in the valence shell 1, 2 and 3 electrons, and non-metallic elements they have 4, 5, 6 and 7 electrons in their valence shell. And in this condition they can receive or they can donate electron to complete their octet. We will take very first example of NaCl. In NaCl, in sodium atom, the configuration of sodium atom is 281. In the last shell, you can see there is one electron in sodium atom. In chlorine atom, the configuration is 287. 287. So you can see in the diagram there are 7 electrons in the valence shell. Valence shell means last shell, last orbit. In that shell there are 7 electrons in chlorine, and in sodium there is 1 electron. In this situation sodium has to lose electron. Then the configuration becomes 2,8 in sodium. 2,8, we will now count the second shell is the outermost shell in sodium atom, that is 2,8. 8 is the outermost shell after giving 1 electron to chlorine atom. Chlorine atom gains 1 electron. Now the chlorine valence shell electrons will be having 8 electrons, including this electron which is donated by sodium atom. Now both atoms have the complete octet, or they have complete this valence shell. In this situation, sodium has to lose one electron, so one positive charge will appear on sodium atom. Now it is called cation. Positively charged particles are called cations. Chlorine has gained one electron. It is extra electron, so chlorine gets negatively charged or anion. This cation and anions are having opposite charge, positive charge and negative charge. So we know that there is attraction between positive and negative charge between these two particles, and this attraction is called electrostatic force, or they form ionic bond or electrovalent bond. Now we will see the structure of KCl or the formation of KCl. KCl means potassium chloride. In potassium chloride, potassium atom has the configuration 2881. In the last shell there is one electron, and Cl atom has 287. In the last shell there are 7 electrons. Now in this situation, sodium has to lose one electron, then it gets its octet complete, and chlorine gains one electron, so chlorine atom will get its octet complete. Both atoms they attain their octet complete. Now since potassium is losing one electron, so potassium will get positively charged and chlorine will get negatively charged as it gains one electron. Positively charged, so it is called cation, and negatively charged, so it is called anion. And because of this positive and negative charge, they have become ions opposite charge. With opposite charge there will be attraction, and this attraction is very strong because it is caused by the ions or the charged particles. So it is electrostatic force of attraction, so it is called ionic bond or electrovalent bond. Second is CaCl2, the formation of CaCl2. In calcium there are 2 electrons in the last shell. The configuration is 2882, and chlorine atom has the configuration 287. In this situation, chlorine atom needs one electron, and calcium atom has 2 electrons in the outermost shells. Chlorine can gain one electron because after gaining one electron its octet will complete. Now the one electron is left with calcium atom. This one electron which is left in the outermost shell in calcium atom will be received by another chlorine atom. Then other chlorine atom also gets negatively charged. So there are 2 negatively charged chlorine atoms. They get attracted by calcium atom, and they form ionic bond because of ion formation. We will see one more example, that is calcium oxide. In calcium oxide, calcium has 2882 electrons, oxygen has 26 electrons, 6 electrons in the outermost shell in oxygen. Oxygen requires 2 electrons. These 2 electrons will be donated by calcium atom because calcium has 2 electrons in the outermost shell. So calcium gets di-negatively charged as it loses 2 electrons. So the oxygen atom gets 2 electrons, so it gets di-negatively charged, and the ions again formed, so they will form ionic bond. Now we will see the properties which are seen in the compound which are having ionic bond. The properties they attain after this kind of bond formation, first is their physical state. All ionic compounds are strong, solid, hard solid. They are hard solid because of extra electrostatic force is present between the ions. Second, they have high melting and boiling point than any other kind of compound like covalent compound. They have higher melting point and boiling point. It is because they have high electrostatic force between the ions. This will cause, or this will require more energy to break the bond. Third, these compounds are soluble in water. Ionic compounds are soluble in water. It is because water is a polar covalent having partial charges in oxygen and hydrogen. So they will dissolve in water. They are soluble in water. Conductivity: all ionic compounds are good conductor of electricity because of ions. They have free electrons, or they are in the ionic forms. These electrons carry the electric charge and they make a good conductor of electricity. In aqueous solution or in the molten state. In solid state they are bad conductor of electricity, but in liquid state or in fused state or in molten state or in aqueous solution they are good conductor of electricity. Covalent compounds or covalent bond. Covalent bonds are the bonds which are formed by the sharing of electrons. In this situation, the atoms of the molecule, they share electrons. The equal number of electrons are shared by both the atoms or more atoms in a molecule. If the sharing is taking place, then the bond is formed, that is covalent bond. So we will understand this type of bond by the example of first hydrogen. Hydrogen has one electron in the outermost shell. Another hydrogen has one electron in the outermost shell. This one electron of hydrogen and this one electron of hydrogen, they share each other, then their duplet will complete. Each hydrogen atom now has two electrons in the outermost shell. Now they are stable. This is H2 molecule. Second, we will discuss about the formation of H2O molecule. H2O molecule, in oxygen atom there are 6 electrons in the outermost shell. We can see in the diagram 2, 6. 6 electrons are there in the last shell or in the valence shell. Hydrogen atom has 1 electron. H2O, there are 2 hydrogen. Each hydrogen atom has 1 electron in the outermost shell. So these 1 electron of each hydrogen will be shared by the oxygen atom, and we can see 1 electron is shared with 1 electron of oxygen and 1 electron of another hydrogen is shared with another electron of oxygen. In this situation, hydrogen gets its duplet complete, each hydrogen gets its duplet complete, and oxygen also gets its octet complete by sharing electrons. Now we will see the example of methane, CH4. In CH4, carbon atom has 4 electrons in the outermost shell and hydrogen atom has 1 electron in the outermost shell. There are 4 electrons in the outermost shell of carbon and there are 4 electrons in 4 hydrogen atoms. Those are unpaired. Each hydrogen share its 1 electron with unpaired electron of carbon to form a single bond. So there are 4 single bonds between carbon and hydrogen. These bonds are called covalent bond. Since 1 electron is being shared, so it is called single covalent bond. Now we will see the example of double covalent bond. Double covalent bond is formed. We will take the example of CO2. In CO2 we can see carbon atom has 4 electrons in the outermost shell and there are 2 oxygen. Each oxygen atom has 6 electrons in the outermost shell. So in this situation 2 electrons of oxygen and 2 electrons of carbon share and this oxygen gets its octet complete. Now carbon has 6 electrons in the outermost shell including the electrons of oxygen already combined. Another oxygen atom has 6 electrons. This oxygen shares its 2 electrons with the 2 electrons of carbon and the double bond is formed. Since they are sharing 2 electrons, so the double bond will be formed between these 2 atoms. Between carbon and oxygen, here double bond is formed and this side also double bond is formed. We will see another example which is having triple covalent bond. Triple covalent bond in nitrogen molecule. In nitrogen atom there are 5 electrons in the outermost shell, which are of them 3 electrons are unpaired and 2 electrons are paired. These unpaired electrons will form the bond. Another nitrogen has the same configuration. Each nitrogen shares its 3 electrons with 3 electrons of another nitrogen atom. Since 3 electrons are being shared, so they will form 3 covalent bond. It is called triple covalent bond. Now we will see the properties of covalent compounds. The bond which is present in the covalent compound is covalent bond, and because of this bond they have some certain properties. They have very low melting and boiling point than electrovalent compounds, and they are insoluble in water, but they are soluble in organic solvents. Some covalent compounds are soluble in water. It is because of polarity. Because covalent compounds are of two types, polar and non-polar. The polar covalent compounds are soluble in water, like H2O, NH3. These are soluble in water. But the non-polar covalent compounds are insoluble in water. Conductivity: all covalent compounds are bad conductor of electricity, and they have less melting and boiling point than ionic compounds. Now coordinate bond. Coordinate bond is formed if any atom is having lone pair of electron. That atom can form coordinate bond. Coordinate bond is formed when one atom donates one pair of electron to the other atom which is already electron deficient atom. Means the atom which require 2 electrons to complete its octet or duplet. If this kind of situation is present between 2 atoms, they will form coordinate bond. Coordinate bond means when the pair of electron is given by one atom only in a molecule, that form coordinate bond. The example of coordinate bonds are ammonium ion and hydronium ion. In ammonium ion, we have already seen the structure of ammonia. In nitrogen, there are 5 electrons, 3 electrons are unpaired. These unpaired electrons share with hydrogen atom to form 3 covalent bonds. But still it is having one lone pair of electron in the valence shell. This lone pair of electron can be given to any electron deficient atom like H positive ion. In H positive ion, it requires 2 electrons to complete it duplet. So in this situation, it will give 2 electrons to hydrogen ion or proton. Now this bond is shown by the arrow, and the head of the arrow remains towards the atom which is receiving the 2 electron, which is receiving the lone pair of electron. Hydrogen is receiving the one pair of electron, lone pair of electron, that will remain in front of this head of the arrow, and the tail of the arrow will remain the atom which is donating this pair of electron.